Hello, my name is John, and I'm going to demonstrate how to create a new node in my CVNode system. To do that, I'm going to create a node that applies a Gaussian blur effect to a frame of an image. And to do this, we'll use the CV Gaussian blur function, which takes in a image, outputs an image, and takes in a kernel size. And we don't need to worry about the rest of the stuff at 0. So to get started, in this first part, I will be just showing off the header. In part 2, I will do the CPP and show off the actual node. I'll try to explain as much of what I'm doing as possible so that you can create a different node yourself. So to start off, we need to create a new class here in node editor. Call it Gaussian blur. Next, and we'll add it to our src.pro. So to begin with, we need our includes. So that's include qt core slash q object. Every node is a Q object, so we can take advantage of Qt's widget system, which we need. So we include qt core Q object, and then we also add a Q underscore object here to let Qt know that this class is a Q object. Next, we have include Qt concurrent to let us take advantage of the Qt's multi-threaded system. That, and then we include graph data connector, which lets us take advantage of the node system's data graph connection system. After this, in order to actually connect the data, we need to include the data itself. So the data model is nodes slash node data model, and all it is it's typically just a wrapper for some primitive type. Sometimes we package a couple of primitive types together, and here's all of the data types. We're going to be using image data because all we need is an image in and an image out. So let's include that as well. Now that we have our data types, we can include all the widgets we need, and these are QLabel, which is just a string that you can show as a label, as a widget. We need a layout to organize our widgets. So let's use QGrid layout, and then we need QLine edit. This lets us take input from the user, and we will use this to have the user decide how big they want the kernel. And since we need the kernel to be a certain size, it needs to be ints that are positive, and it has to be an odd number. We can use the QReg expression validator to validate our input using regular expressions. So next we have a couple namespaces we need to include from Qt nodes. We have port type. We have, copy this down. There's 6 of them. We have port index. We have node data type. Node data model, and we have node validation state. Okay, so Next, our class itself needs to inherit public node data model. This thing, oops, so that it's able to take in all of the data types. Then we have our queue object, our constructor. We do a virtual destructor, so it doesn't use this. Then have our main identifier functions, which is bring caption, just provides a caption for when you hover over the node, and define this here as turn to string literal Gaussian blur. There we go. Next we have our bool caption visible, and we'll just return false on this. Don't really need to show our caption. And we have our toString name, which we can return literal, a unique name for this. We'll just call it Gaussian blur in that. Okay, so these are our main identifier override functions. Next, let's separate it with a public. We can do all of our data type stuff and our validation stuff. So let's start with imports. Imports, this function basically finds out the number of ports that we have in input and in output. And that's what the port type is for determining whether you're doing input or output. So let's comment that. Find number of data ports. Next is the data type. So let's do that. Node data model. Data type. There we go. And what this does is it checks for each port in your n ports that you return. It checks the type of data based on the data types that we have, and it matches them with other data types, and it's able to display them on the node itself. So checks data type for port, and it'll check the port type, whether it's import or output, and then it'll check the port index. And then next is std shared pointer out data. This basically just sends out data that is complete and ready to be sent out of the node. So called to data from function from node, this node. And then we have our last one, void set in data. And this is the opposite of out data. It just sends data into the node from a different node. So called to send data to this node. Okay. Next is the validation states. We have node validation state and string validation validation message, and these are just the state of validation in a node validation state enum, which is this. Returns the current validation state, and then this returns a message for the validation, which we can just define here. Node validation state, model validation state equals node validation state. Let's do warning as the initial one. Do string model validation error equals control sing or correct inputs. Okay, so by default it will assume that nothing is inputted into the node, and it will display the state as a warning and a validation error that says missing or incorrect inputs. So returns enum turn 4 message for validation. Okay, so it's the validation stuff done, and then we can do a full resizable to say whether we want the node to be resizable. I'm just going to return false as well. Okay. Next, we have our overridden slots. So these are mostly for the actual functionality piece and the multi-threaded piece. So void process data is our first one. This is where we will actually do the processing for our data that's coming in. And we'll call this from our second function, void precheck. And this will be called whenever anything that might update the node is detected. It will check whether all of the data has been updated and is ready to be used, as well as if there's any user input, it will check if the user input is ready to be used and whether it's needed. And then it will update the validation states and auto validation error accordingly, and it will also update the data types themselves as to whether they're available to be used. So processing function, and this is check for data check for data readiness. And also, since these are the main functions that we're going to be calling, we actually want them to be slots. And all this means is that so Qt has a signal slot system where signals are emitted, and we can define these signals and call these signals, and then we can connect slots, the functionality of slots to these systems, to these signals, so that whenever the signals are called, the slots are also called. Any slot connected is called, and it's pretty nice. It's decoupled, so we can define these as slots and be able to call them from anywhere. Next is show context menu. This is just something we need to override to enable the right click like this, the right click menu, and then in the right click menu we have void activate. Which will set to activate the node. What we can do, if we find it here is true, then we'll do precheck. Then and since this is the same throughout all of them, we can define it here, and then void activate active equals false. So set file from here. Here it is. All brackets. Okay. So these are the functions that we'll use for the context menu. We won't worry too much about them. Next, we have not a slot. We have multi-threaded process. So it's basically this, but it works on a separate thread. And if you're using it, you would call it from this. So let's do void multi-threaded process. Okay. And this is just processing using separate thread. We don't want any of our processing unless it's very instant to happen on the main thread, because anything we do on the main thread will delay the updating of the visuals of the application itself. So we want to offload as much stuff as we can onto separate thread. And then next we have our actual multi-threaded variables and watchers. So q future void funct. This is our multi-threaded q future, and then we have q future watcher void funct watcher. So this is our function future watcher, and this is basically this. Next is our q label. We'll call this progress bar, and this will just be a label to figure out what's happening with our q function, which is this, and we'll update it ourselves. And then we need a new slot for our void multi. And a new slot for our multi-threaded finished, which is called whenever this completes, and it's called on the main thread. So we have access to our main thread functions from here. And we'll just call it called when multi-threaded this is done. Okay. And we'll connect that to this when it knows that our function has finished. Next, we have our saving functions, qj, so an object save, saves node into JSON, and then we have our void restore JSON object. Right, okay, so, and this just restores, this restores our node from a JSON file into the program, and it defines the specific behaviors that we'll need to identify based on how we parsed our safe function. So data into node. Okay. Next is our ports. private. This will be the ports that we use for the ins and outs of the node. And since both of them are just image data, let's do some shared pointers. Image data, image in, and std shared pointer data image out. So these just hold the data for the image that comes in and the image that goes out, and we make them shared pointers so that we don't have to move any actual data. We just point to different things, and we're able to pull it better by using shared pointer. And next is private. This will be our local variables, and we can use int size x equals 1, int size y equals 1, and this will be reserved for all of our kernels. Then private. Next, we need our update function for our local variables. So we can do a slot and call it void set sizes, and this updates the local so this all this will do is it'll take whatever's in our widget, our line edit widgets, which we'll create shortly after this, and sets them as the size x and size y, so we don't have to reference the widget in our separate thread. Next, we have our private. This will be our actual UI. We'll start by using grid layout. Make a layout for our for controlling our widgets. Next is label. Do label for size x and Q label for size y. These will just tell users that the line edits they're gonna input stuff into is what it is the size of kernel. Do line edit, and this is our actual line edit inputs. Next, put okay, and finally we can add our qreg. Oops. Regular expression validator odd int, and this will make sure that we have an odd positive in our Q line edit. Okay, so that's part 1 of this tutorial. Next part I will make the CPP and show you the actual node working with the image.